Why nearly everything in the universe is spinning. Have you ever noticed that almost nothing in the universe sits still? Planets turn, moons orbit, stars rotate, entire galaxies spiral through the darkness like slow-motion hurricanes made of light. Even the atoms inside your body, the ones that make up your skin and bones and the air in your lungs, they spin too. Tiny electrons whirl around nuclear at speeds we can barely imagine. And yet here you are lying still, feeling perfectly calm, as if nothing around you is moving at all. That stillness you feel right now is one of the strangest illusions in existence. The Earth beneath you is rotating at over 1,000 miles per hour. If you're near the equator, the ground is moving faster than the speed of sound. At this very moment, the planet is also hurtling around the Sun at about 67,000 miles per hour. And the Sun itself, along with all its planets, is circling the center of the Milky Way at nearly 500,000 miles per hour. We are caught in a cascade of spinning motions, wheels within wheels, rotations nested inside rotations. And somehow, we feel none of it. Your coffee doesn't slosh, your breath doesn't waver, the room around you seems perfectly still. But it isn't, nothing is. Tonight, as you rest, I want to talk about why. Why does everything spin? Why can't things just stay still? And what does all this motion have to do with you, lying here in the quiet, breathing slowly, listening to these words? The answers reach back to the very beginning of everything. They touch on the birth of galaxies, the formation of planets, the reason days and nights exist at all. They connect to the tiniest particles we know and the largest structures we've ever observed. And somewhere in all of that spinning, there's a thread that leads directly to this moment, to your body, to your breath, to the gentle turning of the world beneath you. You don't need to follow every detail. You don't need to remember anything. Just let the ideas drift past like clouds. If you fall asleep, that's perfect. The story will still be here, woven into the same motion that carries you through the night. Let's begin with something simple. Why do we feel still when we're actually moving so fast? The answer has to do with a principle that Isaac Newton figured out almost 400 years ago. He called it inertia. It's the tendency of things to keep doing what they're already doing. If something is sitting still, it wants to stay still. If something is moving, it wants to keep moving in the same direction at the same speed. The only way to change that is to push or pull it somehow. Right now, you and the Earth are moving together. The air around you is moving with you. The bed beneath you, the walls of the room, even the atmosphere high above, everything is locked into the same rotation. There's no difference between your motion and the motion of everything around you. And because there's no difference, there's nothing to feel. Think about being on an airplane. When the plane is cruising smoothly at 500 miles per hour, you can sip a drink, read a book, walk down the aisle. It doesn't feel like you're moving at all. But the moment the plane hits turbulence, suddenly you feel everything. The difference is the change. Smooth, constant motion feels like stillness. Only when something shifts do we notice. Earth's rotation is incredibly smooth. It's been turning at nearly the same rate for billions of years. There's no jolt, no wobble you can detect with your body. The spin is so steady that our senses simply ignore it. We evolved to notice things that might matter for survival, a predator approaching, the ground shifting beneath our feet. We didn't evolve to notice the rotation of an entire planet. It was never relevant to staying alive. So we feel still, and in a way, relative to everything around us, we are still. But zoom out far enough, and the motion becomes undeniable. Here's something worth sitting with for a moment. The feeling of stillness isn't a mistake. It's not your body failing to notice something important. It's actually a kind of harmony. You and the earth and the air and the oceans are all moving together, like passengers on a ship so vast and so steady that the journey feels like home. That harmony extends further than you might expect. The moon moves with us too, locked in its own slow orbit, always showing us the same face. The sun carries us along as it travels through the galaxy, and the Milky Way itself drifts through the universe, part of a larger structure called the local group, which is itself falling toward an even larger gathering of galaxies called the Great Attractor. Motion within motion within motion. And at every level, if you're moving with everything around you, it feels like peace. But here's the deeper question. Why is there motion at all? Why didn't the universe just start out still and stay that way? This is where things get interesting and a little strange. When the universe began, about 13.8 billion years ago, it wasn't perfectly uniform. It wasn't a smooth, featureless soup of energy. There were tiny variations, incredibly small differences in density and temperature from one point to another. These variations were so small that we can only detect them now using the most sensitive instruments ever built. But they were there, and they mattered. As the universe expanded and cooled, gravity began to act on those tiny differences. Regions that were slightly denser pulled in a little more matter. Over millions of years, those regions grew, gas clouds formed. And here's the crucial part: those clouds were never perfectly balanced. They always had some slight sideways motion, some tiny amount of what physicists call angular momentum. Angular momentum is just a way of describing rotation. If something is spinning, it has angular momentum. And here's the key rule: angular momentum doesn't just disappear. Once something has it, it keeps it unless something else takes it away. This is called conservation of angular momentum, and it's one of the most fundamental principles in physics. So those early gas clouds, even if they were barely rotating at all, even if their spin was almost too small to measure, they had some angular momentum. And as gravity pulled them together, as they shrank and condensed, that rotation sped up. You've probably seen this happen. Think of a figure skater doing a spin. When she pulls her arms in close to her body, she spins faster. Her angular momentum stays the same, but because her mass is closer to the center, the speed increases. The same thing happened with those early gas clouds. As they collapsed under gravity, any tiny rotation, they had become faster and faster. This is why almost everything in the universe spins, not because something set it spinning, but because it was impossible for things not to spin. Any random motion, any slight asymmetry in those early clouds would get amplified as gravity pulled matter together. Perfect stillness would have required perfect balance, and perfect balance essentially never happens. The universe, it turns out, prefers to move. Let that sink in for a moment. The spinning of galaxies, the orbits of planets, the rotation of the Earth beneath you right now, all of it traces back to tiny imbalances in the early universe. Imperfections in the beginning became the motion we see everywhere today. If everything had been perfectly smooth, perfectly even, nothing would have clumped together. There would be no stars, no planets, no you. The fact that things spin is connected to the fact that anything exists at all. There's something almost comforting in that. The motion isn't random chaos. It's the echo of the universe's birth, still playing out after billions of years. Every rotation is a kind of memory, a trace of how things began. And you're part of that memory. The atoms in your body were forged in ancient stars, stars that formed from spinning clouds of gas, clouds that inherited their motion from the earliest moments of time. The iron in your blood, the calcium in your bones, the oxygen you're breathing right now, all of it cycled through cosmic rotations before it ever became part of you. You are quite literally made of ancient spin. Let's slow down for a moment. Take a breath if you like. Feel the weight of your body against whatever surface is supporting you. Notice that even now, as we talk about cosmic motion and the birth of galaxies, you're still here, still resting, still breathing. The universe is vast and old and full of movement, but this moment is quiet. Both things are true at once. Now let's go a little deeper. If the early universe had these tiny variations that led to rotation, where did those variations come from? How did the very first imbalances arise? This takes us into territory that even physicists find strange. The answer, as best we understand it, has to do with quantum mechanics, the rules that govern the behavior of the smallest things in existence. At the quantum level, nothing is ever perfectly still. Even in a complete vacuum, even in the emptiest space imaginable, there are tiny fluctuations happening constantly. Particles pop into existence and vanish again. Energy levels jitter and shift. These fluctuations are built into the fabric of reality itself. They're not caused by anything, they're just how the quantum world works. In the very early universe, when everything was compressed into an unimaginably small space, these quantum fluctuations were happening too. And then something remarkable occurred. the universe underwent a period of incredibly rapid expansion called inflation. In a tiny fraction of a second, the universe grew from something smaller than an atom to something larger than a galaxy. During this expansion, those quantum fluctuations got stretched. What had been microscopic variations became cosmic-scale differences in density. The randomness of the quantum world was imprinted onto the structure of the universe itself, and those imprinted variations became the seeds of everything that followed: galaxies, stars, planets, and all the spinning motion we see today. So in a very real sense, the rotation of the Earth beneath you, the spiral of the Milky Way above you, all of it can be traced back to quantum uncertainty in the first fraction of a second after the Big Bang. The tiniest randomness became the largest structures. The most fleeting fluctuations became the most enduring motions. It's almost too strange to fully grasp, and that's okay. You don't need to understand quantum mechanics to feel the weight of your body, to notice your breath, to sense the quiet of the room around you. But it's worth knowing that the stillness you feel is woven from the same fabric as the spinning of galaxies. The same rules govern both. The same story connects them. Let's bring this back down to Earth, literally. Our planet has been spinning for about 4.5 billion years. When it first formed, it was rotating much faster than it does now. Days were only about 6 hours long. Over time, the moon's gravity has been slowing Earth's rotation, pulling on the oceans, creating tides, and gradually draining away some of our planet's angular momentum. This process is still happening. Every century, the day gets about 1.7 milliseconds longer. It's far too slow for anyone to notice in a lifetime, but over millions of years, it adds up. The dinosaurs experienced shorter days than we do, and hundreds of millions of years from now, days will be noticeably longer than they are today. The moon is connected to this in another way too. As it pulls on the Earth and slows our rotation, it's also drifting away from us, very slowly, about 1.5 inches each year. Astronauts left reflectors on the lunar surface during the Apollo missions, and scientists bounce laser beams off them to measure this drift with incredible precision. The moon that our distant ancestors watched is not quite in the same place as the moon you might see tonight. It's a little farther away, and we're spinning a little slower. This is the gentle exchange of angular momentum, the same principle that governs figure skaters and collapsing gas clouds, playing out between our planet and its companion over billions of years. And here's something beautiful about it. The moon's gravity hasn't just slowed the Earth, it's also stabilized it. Without the moon, our planet's axis would wobble much more dramatically over time. The tilt that gives us seasons would shift unpredictably. Climates would swing wildly. Life as we know it might never have had the stability it needed to evolve. So the same force that's slowly stealing our spin is also the force that makes our world livable. The moon is both anchor and brake, holding us steady while gently slowing us down. You're lying on a planet that's been cradled by this relationship for longer than complex life has existed. The rhythm of your days, the cycle of seasons, the very stability that allows you to rest peacefully right now, all of it comes from this ancient gravitational dance. Take another breath, let your body settle a little more. The Earth is turning beneath you as it has for billions of years, as it will for billions more. You don't need to do anything about it. You don't need to keep track of it. It just continues, smooth and silent, carrying you through the night. Now let's look outward, past the moon, past the sun, into the wider universe. Because Earth's rotation is just one small part of a much larger pattern. Our sun rotates too. It takes about 27 days for the sun to complete one rotation at its equator, but the sun isn't solid like the Earth. It's a massive ball of hot gas, and different parts of it rotate at different speeds. The equator spins faster than the poles. This differential rotation creates complex magnetic fields that twist and tangle, eventually producing sunspots and solar flares. The sun also has its own orbit. It's moving through the Milky Way at about 450,000 miles per hour, carrying all its planets along with it. One complete circuit around the galaxy takes about 230 million years. The last time we were in this part of the galaxy, dinosaurs hadn't even appeared yet. The next time we return to this spot, whatever lives on Earth will be unrecognizably different from us. And the Milky Way itself is rotating too. It's a vast spiral, 100,000 light-years across, containing hundreds of billions of stars, all of them orbiting the galactic center. That center harbors something extraordinary, a supermassive black hole called Sagittarius A*, about 4 million times the mass of our Sun. Everything in the galaxy, including us, is slowly spiraling around it. When you look up at the night sky, if you can see the faint band of the Milky Way stretching overhead, you're looking at the edge of this great rotating disk. You're inside it, moving with it, part of its slow cosmic pinwheel. And even galaxies don't move alone. The Milky Way is part of a small cluster called the Local Group, which includes the Andromeda Galaxy and a few dozen smaller galaxies. The whole group is drifting through space together, bound by gravity, moving toward a region called the Great Attractor, a massive concentration of galaxies pulling everything in our corner of the universe toward it. Motion within motion within motion, rotations nested inside other rotations. And at every scale, from atoms to galaxy clusters, the same principle holds: angular momentum is conserved and spin persists. It's easy to feel small when you think about these scales. Billions of light years, billions of years, hundreds of billions of stars. The numbers are so large they stop meaning anything. But here's another way to think about it. All of that motion, all of that spinning, it's not separate from you. It's not happening somewhere else to someone else. You're in it. You're made of it. The atoms in your body have been part of this cosmic motion since the beginning. You're not watching the universe from outside. You're a piece of it, resting for a moment, breathing quietly while the whole thing turns. Let's pause here for a while. Let the ideas settle. You don't need to hold on to any of them. They'll still be true whether you remember them or not. The Earth is spinning, the Moon is drifting, the Sun is orbiting, the galaxy is rotating. And you're here, warm and safe, part of all of it. Breathe in slowly and out again. The motion continues, but you can rest within it. Now I want to talk about something that might seem unrelated at first, but it connects to everything we've discussed. I want to talk about time. What is time really? We measure it with clocks and calendars. We feel it passing. We remember the past and anticipate the future. But what actually is it? One answer, the one that physics gives us, is that time is deeply connected to motion. In fact, you could argue that time and motion are almost the same thing. Think about how we measure time. The original definition of a second was based on the Earth's rotation, one day divided into 24 hours, each hour into 60 minutes, each minute into 60 seconds. Later, we switched to atomic clocks, which count the vibrations of cesium atoms. Those atoms don't tick like a clock. They oscillate, they move, they spin. The most precise timekeeping we have is based on the motion of particles. Even the way we experience time is connected to motion. Your sense of a moment passing comes from changes, neurons firing, chemicals shifting, your heart beating. If nothing in your body changed, if every atom froze in place, you wouldn't experience time at all. Time, for us, is the feeling of things happening. And on a cosmic scale, time is literally created by rotation. The Earth's spin gives us days. Its orbit around the Sun gives us years. The Moon's orbit gives us months. Before clocks existed, before anyone thought to measure seconds, time was just the pattern of motion in the sky. So when we ask why everything spins, we're also asking something about time itself. The rotation of the universe isn't just movement through space. It's the heartbeat of time. Without spin, without motion, time would have no rhythm. There's something even stranger that physics tells us about this connection. According to Einstein's theory of relativity, time isn't the same everywhere. It flows at different rates, depending on how fast you're moving and how strong the gravity is around you. If you're moving very fast, close to the speed of light, time slows down for you compared to someone standing still. If you're near a very massive object, like a black hole, time also slows down. This isn't just theory, it's been measured with incredible precision. Clocks on satellites run slightly faster than clocks on the ground because they're farther from Earth's gravity. GPS systems have to account for this difference constantly, or they'd give you the wrong location. Rotation intensifies these effects. A spinning object drags spacetime around with it, literally twisting the fabric of reality. Near a rapidly rotating black hole, this effect becomes extreme. Time itself gets caught in the spin, stretched and bent into shapes our intuition can't easily grasp. But even here on Earth, the effect exists. Our planet's rotation, gentle as it is, creates a tiny twist in spacetime around us. Scientists measured this using satellites with incredibly precise gyroscopes, confirming what Einstein's equations predicted. The Earth doesn't just spin in space, it spins space itself, ever so slightly. You're lying inside that twist right now. The time flowing through your body is subtly shaped by the rotation of the world beneath you. The effect is tiny, far too small to notice, but it's real. Your experience of this moment is slightly different than it would be on a planet that didn't rotate. Time and spin, woven together at every scale. Let that idea drift for a while. You don't need to chase it. Just let it be there, like a quiet hum beneath the silence. The universe is moving, and that movement creates the time you're resting in. Now let's think about what happens when rotation gets extreme. What happens when things spin so fast that the normal rules start to break? The fastest spinning objects we know of are neutron stars. These are the collapsed cores of massive stars that exploded. When a star much bigger than our sun dies, its outer layers blast away in a supernova, but the core crushes inward under its own gravity. What's left is a ball of matter so dense that a teaspoon of it would weigh billions of tons. And because angular momentum is conserved, because all that spin from the original star gets concentrated into a tiny space, neutron stars rotate unbelievably fast. Some of them spin hundreds of times per second. Imagine something the size of a city, weighing more than the sun, rotating faster than a kitchen blender. The surface is moving at a significant fraction of the speed of light. Gravity there is about 100 billion times stronger than on Earth. Time runs measurably slower on a neutron star than it does here. These objects pulse beams of radiation from their magnetic poles. When those beams sweep across our line of sight, we see a flash, like a cosmic lighthouse. We call them pulsars, and their pulses are so regular that they rival the best atomic clocks. Some pulsars have been spinning at nearly the same rate for millions of years, ticking away in the darkness, keeping time for no one. There's something almost hypnotic about that image. A collapsed star, impossibly dense, spinning in the void, flashing its signal into the cosmos. It doesn't know we are watching. It doesn't know anything. It just spins because physics says it must, because the angular momentum has to go somewhere, and it chose to become this, a tireless rotating beacon in the dark. And then there are black holes. When even a neutron star isn't enough to resist gravity, when the collapse continues all the way down, a black hole forms. The matter falls inward until it reaches a point of infinite density, what we call a singularity. Around that singularity is a boundary called the event horizon, the point of no return, where gravity becomes so strong that not even light can escape. Black holes can spin too. In fact, most of them do, because the stars they came from were spinning, and that angular momentum doesn't just vanish. A rotating black hole is called a Kea black hole, named after the physicist who first solved Einstein's equations for this case. Near a spinning black hole, spacetime gets dragged along with the rotation. There's a region outside the event horizon called the ergosphere, where space itself is moving so fast that nothing can stand still. You could fire your engines at full power, pointed directly away from the black hole, and space would still carry you around, swept up in the spin. Inside the ergosphere, stillness is physically impossible. This is rotation taken to its absolute extreme, not just matter spinning, but space itself, twisted into motion, dragging time along with it. Near a fast-spinning black hole, the future and the past start to curve in strange ways. Theoretical physicists talk about closed time-like curves, paths through spacetime that loop back on themselves. Whether these are real possibilities or just mathematical curiosities, we don't know yet. But the equations allow them, hinting at how deeply rotation and time are intertwined. You're lying here in a quiet room, breathing slowly, and somewhere in the universe, there are black holes spinning so fast that time itself bends around them. The same physics governs both, the gentle rotation of the Earth beneath you and the ferocious spin of those cosmic whirlpools. It's all connected by the same laws, the same principles, the same conservation of angular momentum that started in the earliest moments of the universe. The difference is just scale and intensity and time. Let your mind rest on that for a moment. You don't need to understand black holes or neutron stars. You don't need to picture the ergosphere or calculate the frame-dragging effect. Just know that the rotation you're part of, the soft, slow turning of the Earth, is the gentle end of a spectrum that stretches all the way to the most extreme objects in existence. You're part of the same story they are. The same motion runs through everything. Take a slow breath, feel the stillness of your body, and know that the stillness is an illusion, a beautiful one, made of motion so smooth you can't detect it. Now I want to talk about something closer to home. I want to talk about how rotation shapes life itself. We've talked about how the Earth's spin creates day and night, how it drives weather patterns, how it stabilizes our planet through its relationship with the Moon. But the effects go even deeper than that. Rotation is woven into biology in ways that might surprise you. Every living thing on Earth has an internal clock. Scientists call it a circadian rhythm, from the Latin words for about a day. This clock regulates when you feel awake and when you feel sleepy, when your body releases certain hormones, when your cells repair themselves, when your mind is sharpest, and when it needs rest. And this clock evolved to match the rotation of the Earth. For billions of years, life on this planet has experienced the cycle of light and dark created by our spinning world. Organisms that could anticipate that cycle, that could prepare for sunrise before it happened, that could rest efficiently during the hours of darkness, had an advantage. Over countless generations, this external rhythm became an internal one. The rotation of the Earth is now encoded in your genes. Even if you lived in a cave with no sunlight, even if you had no clocks or schedules, your body would still cycle through roughly a 24-hour pattern. It might drift a little without external cues, but the basic rhythm would persist. You're carrying the Earth's rotation inside you, written into the molecular machinery of your cells. This is true for almost all life on Earth. Bacteria have circadian rhythms, plants have them. Insects, fish, birds, mammals, everything that has evolved under the turning sky has internalized that turning. The rotation of our planet isn't just an astronomical fact, it's a biological one too. And it goes even further than daily rhythms. The Earth's tilt, which gives us seasons, has shaped the migration of birds, the hibernation of bears, the flowering of plants. The Moon's orbit, which influences tides, has shaped the breeding cycles of marine creatures, the feeding patterns of shore birds, the entire ecology of coastal zones. The angular momentum of our planet and its moon is woven into the fabric of life. You're feeling sleepy right now, perhaps, or relaxed or drifting. That feeling comes partly from your circadian rhythm, which knows that this is a time for rest. The Earth is turning you away from the sun, into the shadow, into the night. And your body knows this, not because you looked at a clock, but because millions of years of evolution have taught it to read the rotation of the world. There's something deeply reassuring about that, I think. You're not fighting against the night when you rest. You're moving with it. Your body is doing exactly what the rotation of the Earth has trained it to do. Sleep isn't an interruption of life. It's part of the same rhythm that drives everything else, the same motion that spins galaxies and orbits planets and pulses neutron stars. You belong to this turning. You've always belonged to it. And tonight, as you rest, you're doing exactly what you were made to do. Let's slow down a little more. The ideas can become quieter now. There's no rush. The universe is spinning. The Earth is spinning. Your atoms are spinning. And you're here, breathing, resting, letting it all continue without your effort. You don't have to hold anything together. You don't have to keep track of any of this motion. It keeps itself. The angular momentum persists, as it has for billions of years, as it will for billions more. All you have to do is rest. The night is a kind of rotation too. The Earth turning away from the sun, giving you darkness, giving you quiet. It will turn back again in a few hours, bringing light, bringing morning. But that's not your concern right now. Right now, you're in the middle of the turn, in the soft part of the cycle, in the rest that the rhythm requires. Let your breathing slow, let your thoughts drift. The story continues, but you can let it fade into background, like music heard from another room. There's one more thing I want to mention, something about the future of all this spinning, something about how it ends, or whether it ends at all. The universe, as far as we can tell, will keep expanding. The galaxies are drifting apart from each other, carried by the expansion of space itself. In the very distant future, billions of years from now, the galaxies will be so far apart that light from one will never reach another. Each galaxy will become an island, alone in an enormous dark sea. But even then, the rotation will continue. Galaxies will keep spinning, stars will keep orbiting, planets will keep turning. The angular momentum doesn't disappear just because things are far apart. It persists, spreading out, thinning, but never truly vanishing. Eventually, stars will burn out. New stars will stop forming. The universe will grow cold and dark. Physicists call this the heat death, the point where all the energy has spread out so evenly that nothing interesting can happen anymore. No temperature differences, no energy flow, no life. Just a vast, cold, quiet emptiness. Even then, there will still be rotation. Black holes will still spin, slowly losing energy over unimaginable timescales through a process called Hawking radiation. Particles will still have their intrinsic quantum spin. The angular momentum that began in the first moments of the universe will still exist, diffused across an almost empty cosmos, but not gone, never entirely gone. There's something strange and beautiful about that. The universe might end in stillness, but it will be a stillness made of motion too faint to notice. The same illusion you feel right now, lying on a spinning planet and feeling perfectly calm, will be the final state of everything. Motion so smooth, so spread out, so quiet, that it becomes indistinguishable from rest. In a way, the universe will end the same way your night ends. The spinning continues, but gently, imperceptibly, fading into something that feels like peace. You don't need to worry about that future. It's so far away that the numbers stop meaning anything. Trillions of years, trillions of trillions, numbers that your mind can name but not really grasp. What matters is this night, this breath, this moment in the gentle spin of a quiet planet. The universe is very old, and it will last for much longer than we can truly understand. But right now, you're here, you're part of it, you're made of its motion and shaped by its spin. And you're resting, which is exactly what you should be doing. Let the ideas go quiet now. Let the spinning continue without your attention. It doesn't need you to watch it. It doesn't need you to understand it. It just goes on, smooth and endless, carrying you through the dark. Your breath is slowing, your body is heavy. The turning of the earth is beneath you, steady as it's always been. This is the rhythm you were born into. The rhythm of a rotating world, a spiraling galaxy, a universe that has been spinning since before time had meaning. You're not separate from it. You're not watching it from outside. You're in it, made of it, moving with it. And tonight, as the earth turns you through the darkness, you can rest. You can let go. The motion takes care of itself. It always has. The stars are out there, spinning in their orbits. The moon is drifting slowly away. The galaxy is wheeling through the void. And you're here, breathing, resting, part of all of it. Nothing is required of you, nothing at all. Just rest, just breathe. The universe is spinning, and you can sleep within its turning. There's a quietness to the way things move when you stop trying to track them. The earth doesn't need your attention to keep rotating. The stars don't wait for you to watch them. The whole vast machinery of the cosmos continues on its own, has been continuing for billions of years, will continue for billions more. Your awareness of it is a small flicker in an enormous process, a brief moment of noticing in an endless unfolding. And that's not sad, it's actually a kind of freedom. You can let go of needing to understand everything. You can let go of keeping track. The universe doesn't require your vigilance to persist. It's been doing just fine without human observers for most of its existence, and it will do fine long after we're gone. Your job, tonight, is just to rest inside it, to be a small part of the motion, breathing and still for a little while. Let me tell you about something else that spins, something you might not have thought about: hurricanes. When warm, moist air rises from tropical oceans, it creates a low-pressure zone. Surrounding air rushes in to fill that gap, but because the Earth is rotating, that incoming air doesn't travel in a straight line. It curves, deflected by the planet's spin. In the northern hemisphere, it curves to the right. In the southern hemisphere, it curves to the left. This is called the Coriolis effect, and it's the reason hurricanes rotate. In the north, they spin counterclockwise. In the south, clockwise. It's not because of some preference in nature, not because one direction is better than the other. It's purely a consequence of geometry, of living on a spinning sphere. The rotation of the entire Earth imprints itself onto the rotation of storms. If you've ever watched footage of a hurricane from space, you've seen this massive spiral of clouds, hundreds of miles across, slowly wheeling around a calm eye at the center. That spiral is the Earth's rotation made visible, the planet's spin written in clouds. And it's not just hurricanes. The same effect shapes ocean currents, the great conveyor belts of water that circulate around the globe, carrying heat from the tropics toward the poles, moderating climates, making some places livable that would otherwise be frozen or scorched. The Coriolis effect bends these currents, creating the gyres, those huge rotating systems that dominate each ocean basin. Rotation all the way down, from the galaxy to the planet to the atmosphere to the ocean. The same principle playing out at every scale. There's something almost musical about it when you think about it this way. Different tempos, different scales, but all part of the same underlying rhythm. The galaxy rotates once every 230 million years. The Earth rotates once every 24 hours. A hurricane might rotate once every few hours. The electrons in your atoms rotate billions of times per second. Different speeds, different sizes, but all governed by the same laws. All part of the same vast, intricate dance. You're lying inside that dance right now. The air you're breathing was shaped by the Coriolis effect. The temperature of the room is influenced by ocean currents driven by planetary rotation. The length of the night, the timing of the dawn, the cycle of your own sleepiness and wakefulness, all of it comes from spin. And you don't have to do anything about it. You don't have to participate consciously. You just have to be here. And the dance continues around you and through you, whether you notice or not. Let your attention soften. You don't need to hold onto these ideas. They're not going anywhere. The hurricanes will keep spinning. The currents will keep flowing. The Earth will keep turning beneath you. None of it needs your effort. I want to tell you about something that happened a long time ago, when the Earth was young. About 4.5 billion years ago, our planet was a very different place. It had just formed from the same disk of gas and dust that made the sun. It was hot, molten, chaotic, and it was spinning much faster than it does now. Days were only about 6 hours long. Then something remarkable happened. Another young planet, about the size of Mars, came hurtling through the inner solar system and crashed into Earth. This was not a gentle collision. The impact was so violent that it melted much of both worlds. The collision happened at an angle, a glancing blow that sent an enormous spray of debris into orbit around the Earth. That debris eventually came together to form the Moon. This is called the giant impact hypothesis, and while we can't be completely certain about events that happened so long ago, the evidence strongly supports it. The Moon's composition matches what we'd expect from a mixture of Earth's mantle and the impacting body. The Moon's orbit and the Earth's rotation are consistent with this kind of collision. The impact did more than create the Moon. It gave Earth much of its angular momentum. The angle and speed of the collision set our planet spinning faster, and that spin has been gradually slowing ever since, drained away by the Moon's tidal pull. So the Moon is both the product of a catastrophic collision and the gentle break that's been slowing us down ever since. The same event that gave us our companion also gave us our rotation, and the relationship between the two has shaped the past 4 billion years of Earth's history. Without the Moon, our planet's axis would wobble chaotically, seasons would be unpredictable, climate would swing wildly from one extreme to another. Life might have evolved very differently or not at all. The stability we take for granted, the relatively calm conditions that allowed complex life to emerge, all of it owes something to that ancient collision and the gravitational dance that followed. You're lying here tonight because, billions of years ago, two worlds crashed into each other and started spinning together. The echoes of that collision are still playing out, in the length of your day, in the tides of the ocean, in the fact that the moon is slowly drifting away. It's strange to think about. The stability of your life, the predictability of morning and night, it all comes from chaos so ancient and so violent that nothing on Earth today remembers it directly. But the evidence is written in the rotation of the planet, in the orbit of the moon, in the physics that governs everything that moves. You're connected to that ancient event. Your circadian rhythm is calibrated to a rotation that was set in motion by a collision. Your sense of time is shaped by the spin that began in fire and has been gently fading into steadiness ever since. And tonight, as you rest, the moon is out there somewhere, maybe visible, maybe hidden by clouds or the horizon. It's drifting away from you at about 1.5 inches per year, continuing a journey that started with a catastrophe and will eventually end with it so far away that it no longer stabilizes our world. But that's a very long time from now, so distant that it's not worth worrying about. What matters is tonight, this gentle turn of the Earth, this quiet moment in the long relationship between our planet and its moon. Breathe slowly. The moon is out there, whether you can see it or not. The Earth is turning beneath you. The ancient collision is just an echo now, a faint memory preserved in the way things move. Let's drift into something even quieter now, something about the smallest scales of rotation. We've talked about galaxies and planets and storms, but rotation happens at scales far smaller than anything you can see. It happens inside atoms. Every electron, every proton, every particle has a property called spin. In quantum mechanics, this isn't quite the same as what we usually mean by spinning. It's more abstract than that, a mathematical description of an intrinsic quality that all particles have. But it behaves like rotation in many ways. Particles with spin interact with magnetic fields. They create their own tiny magnetic fields. The chemistry of everything you see around you depends on the spin of electrons. This is why magnets work. This is why MRI machines can image the inside of your body. This is why certain materials conduct electricity and others don't. All of it traces back to the quantum spin of particles. And here's something truly strange. The spin of particles is quantized. It doesn't vary smoothly. An electron always has the same amount of spin, a fixed value. It can point in different directions, but the magnitude is always the same. This is one of the deep mysteries of quantum mechanics, that certain properties come in discrete chunks rather than continuous ranges. This quantum spin has been around since the beginning of the universe. When particles first formed in the hot, dense conditions after the Big Bang, they already had their spin. They didn't acquire it later. It was part of what made them particles at all. So in a very real sense, the rotation inside your atoms is as old as the universe itself. The electrons orbiting the nuclei in your cells carry spin that has been conserved since the first moments of time. You're made of ancient rotation at the smallest scales imaginable. It's hard to wrap your mind around this. The quantum world is so different from everyday experience that our intuitions don't really apply. But you don't need to understand it fully. Just know that the motion is there at every level all the way down. Rotation nested inside rotation, from the spinning of galaxies to the quantum spin of electrons. You're built from these smallest rotations. Every chemical bond in your body involves electrons with spin. Every signal in your nervous system is carried by particles with quantum angular momentum. The thoughts drifting through your mind right now are patterns of activity in neurons that depend on the spin of subatomic particles. It's all connected. The same principles that govern the rotation of black holes also govern the spin of electrons. The same conservation laws that keep galaxies turning also keep your atoms stable. You're part of one continuous fabric of motion woven at every scale. And tonight, you can rest inside that fabric. The motion doesn't require your effort. It sustains itself as it has since the beginning, as it will until the very end. Let your thoughts slow, let the images fade. The spinning continues at every scale, whether you're thinking about it or not. There's a kind of poetry to the idea that nothing is truly still. Even the most solid objects, even the most motionless moments, are made of constant movement. The atoms in your body are vibrating with thermal energy. The electrons are orbiting. The earth is turning. Everything is in motion, but the motion is so consistent, so harmonious, that it feels like peace. This is what the universe has discovered over billions of years: how to be in motion in a way that feels like rest. Not true stillness, which would be a kind of death, but dynamic equilibrium, a balance of forces and spins that creates stability. Your life is part of that balance. Your body maintains itself through countless internal motions: metabolism, circulation, the firing of neurons, the replication of cells. All of it is movement. All of it is energy transforming from one form to another, and yet you feel like a single, stable being, resting in the quiet. The illusion of stillness is one of the universe's kindest gifts. It lets you rest even while everything is moving. It lets you feel peaceful even inside the spin. Accept that gift tonight. Don't try to see through the illusion, just rest inside it. The motion will take care of itself. Let me tell you one more thing about the very distant past and the very distant future and how they might be connected. In the early universe, everything was hot and dense and chaotic, but even then, there was a kind of order. The laws of physics were already in place. Angular momentum was already being conserved. The patterns that would eventually become galaxies and stars and planets were already being set. Those patterns came from quantum fluctuations, those tiny random variations that got stretched by inflation and became the seeds of structure. The universe didn't design these patterns consciously. They emerged from the interaction of fundamental laws with random chance. But the result was order, complexity, beauty. And now, billions of years later, some of that complexity has become conscious. You're part of it. Your brain, made of atoms forged in stars, organized by billions of years of evolution, calibrated by the rotation of the Earth, is aware of itself and the universe around it. The patterns have woken up. This might be rare in the cosmos. We don't know for sure. We haven't found other conscious beings yet, but even if life and awareness are scattered thinly across the universe, they exist. They emerged from the same spinning, expanding, cooling process that made everything else. You could think of consciousness as the universe noticing itself. The same matter that formed in the Big Bang, the same angular momentum that's been conserved since the first moments, has arranged itself into something that can ask questions, that can wonder about why things spin, that can feel the stillness of a quiet room and sense the hidden motion beneath it. This isn't mystical or supernatural. It's just what happens when matter gets complex enough. Consciousness is part of the natural world as much as gravity or electromagnetism or spin. It emerges from physics, from chemistry, from biology. It's the universe looking at itself through the eyes it grew. And tonight, those eyes are tired. That awareness is ready to rest. The universe will keep spinning whether you're awake or not. But for a little while, you can let go of the noticing. You can sink into the quieter kind of existence that doesn't require thought. The motion continues. The stars turn, the atoms spin, and you rest, part of it all, but not needing to watch. This is the natural rhythm. Awareness rises and falls. Wakefulness gives way to sleep. The circadian rhythm, shaped by planetary rotation, carries you through cycles of consciousness and unconsciousness, alertness and rest. You've been on this ride since the day you were born. You'll be on it until the end. And it's okay. It's more than okay. It's how things work. It's how they've always worked. Let the night carry you. Let the turning earth rock you gently. The universe is spinning and you can sleep now. We've traveled a long way tonight, from the edges of galaxies to the spin of electrons, from the birth of the moon to the distant future of the cosmos. But all of it leads back here, to this quiet moment, to your breath, to the weight of your body, to the soft feeling of rest. The motion doesn't stop. It never stops. but you can let it fade into the background, like the hum of a familiar room, like the sound of wind outside a window. It's always there, but you don't have to listen. The earth is turning. The stars are wheeling overhead, invisible beyond the ceiling and the clouds and the glow of cities. The galaxy is spiraling. The universe is expanding. And you're here, a tiny piece of it all, made of the same stuff, governed by the same laws, resting for a moment in the endless motion. This is enough. This is everything, actually, just being here, breathing, resting. The universe doesn't need you to do anything else right now. It's taken care of itself for billions of years. It can handle one more night while you sleep. Let your thoughts slow down. Let them become less distinct. The ideas are still there somewhere, but you don't have to hold them. They'll wait. The spinning will wait. Everything continues whether you're tracking it or not. Your breath is soft now. Your body is heavy. The night is deep and quiet. The rotation continues beneath you and around you and inside you. The ancient spin of atoms, the slow turn of the planet, the vast wheeling of stars. You're part of it. You've always been part of it. And tonight, you can rest inside the motion, cradled by the turning, carried through the dark. Sleep now, the universe is spinning, and all is well. The night continues. Nothing is required of you. Just rest. The motion takes care of itself. It always has. The quiet deepens when you stop waiting for something to happen, when you let go of the expectation that there should be a next thing, a next thought, a next moment that matters more than this one. The universe doesn't wait. It just continues, smooth and unhurried, and you can continue with it. There's something I haven't mentioned yet, something about the way rotation connects to memory. Not human memory, not the kind stored in your brain, but a deeper kind. The kind written into the structure of things. When a star collapses into a neutron star or a black hole, it doesn't forget that it was once spinning. The angular momentum is preserved. The new object carries the rotation of its former self, concentrated and intensified. In a sense, the black hole remembers the star. When galaxies collide and merge, their combined rotation is a blend of what each one carried before. The new galaxy holds the memory of both. The angular momentum tells a story if you know how to read it. Even the cosmic microwave background, that faint glow left over from the early universe, carries patterns that encode how matter was moving nearly 14 billion years ago. Scientists study those patterns like historians studying ancient texts. The rotation is still there, frozen in light, readable across the ages. The universe keeps records in motion. Everything that has ever spun leaves traces that persist. And you're part of that record too. The atoms in your body were forged in stars that rotated. They were scattered by supernovae and gathered into new clouds that collapsed and spun. They became part of the Earth, which rotates, and part of you, whose cells contain molecular structures that twist and spiral in specific directions. Your DNA is a double helix. It spirals. The direction of that spiral is the same in every living thing on Earth, a choice made billions of years ago when life was just beginning, preserved ever since. This is called chirality, a kind of handedness, and it connects to rotation in deep ways that scientists are still working to understand. Some researchers think the chirality of life might trace back to the way light from young stars was polarized, twisted in a particular direction as it passed through magnetic fields in space. That twisted light might have favored certain chemical reactions over others, selecting for molecules that spiral one way instead of the other. If true, the handedness of your DNA could be a fossil of ancient starlight, rotation encoded in the chemistry of life. You're carrying that fossil inside every cell. The spiral of your genetic code is a kind of memory, a trace of cosmic spin preserved in biology. You didn't choose it. You weren't there when it was set, but it's part of you nonetheless. This is what I mean when I say the universe remembers through motion. Not consciously, not intentionally, but structurally. The shapes of things, the directions they turn, the angular momentum they carry, all of it is information, preserved across billions of years. And tonight, that information rests with you. The spiral of your DNA, the rotation of the Earth, the the spin of electrons in your atoms, all of it is here, in this quiet moment, in your breathing body. Let that thought settle. You don't need to do anything with it. Just let it be part of the stillness. There's a question I've been circling around, and maybe now is the time to approach it more directly. Why does any of this matter? Why think about cosmic rotation when you're trying to sleep? Here's one answer, because it puts things in perspective. The worries you carry, the tasks waiting for tomorrow, the things you didn't finish today, they're real, but they're small. They exist on a single planet, in a single lifetime, within a universe that has been spinning for almost 14 billion years and will continue for trillions more. This isn't meant to make your concerns feel unimportant. Your life matters, your feelings matter, but they exist within a context so vast that the context itself becomes a kind of comfort. Whatever is troubling you, it's happening on a spinning world that doesn't know or care about human worries. The Earth will turn tonight whether you solve your problems or not. The stars will continue their orbits. The galaxies will keep spiraling. There's freedom in that, permission to let go, at least for now. The universe doesn't need you to fix everything before morning. It's been getting along without human intervention for most of its existence. It can handle a few more hours while you rest. This is one of the gifts of thinking about scale, not to diminish yourself, but to release yourself, to recognize that you're part of something so much larger that your individual effort, while valuable, isn't required to keep reality running. The motion continues, with or without your attention, with or without your worry. So let the worry go, if you can. Let it drift away like a leaf on a slow current. The current doesn't need the leaf to keep flowing, and you don't need to hold on to every thought to keep being yourself. The night is here for rest. The rotation provides it. Accept the gift. Let me tell you about tides. You probably know that tides are caused by the moon. Its gravity pulls on the Earth, and the oceans respond. The water on the side of the Earth nearest the moon gets pulled toward it, creating a bulge. And there's another bulge on the opposite side, where the Earth itself is being pulled away from the water. These bulges are the tides. As the Earth rotates beneath them, different coastlines experience high tide and low tide. The rhythm of the tides is connected to the rotation of the Earth and the orbit of the moon, both of them spinning, both of them dancing together. But here's something you might not have considered. The tides are slowing the Earth down. As the tidal bulges move across the planet, there's friction between the water and the ocean floor. That friction converts some of the Earth's rotational energy into heat. The energy doesn't disappear, but it changes form. And the result is that the Earth spins a little more slowly with each passing year. The moon is involved in this too. The tidal bulges on Earth are slightly ahead of the moon's position because the Earth's rotation carries them forward. That offset creates a gravitational tug on the moon, pulling it forward in its orbit, causing it to drift away from Earth. So the tides are a mechanism of exchange. The Earth loses rotational energy. The moon gains orbital energy. The distance between them slowly increases, and the days get longer. This has been happening for billions of years. When the moon first formed, it was much closer, and the Earth spun much faster. Tides were enormous, probably hundreds of feet high in some places. The relationship between Earth and Moon has been moderating ever since, settling into the gentler rhythm we know today. And it will continue into the future. Billions of years from now, the Earth and Moon will be tidally locked to each other, each showing the same face to the other, the way the Moon already shows only one face to us. Days will be much longer then, perhaps lasting what we would now call weeks. The tides will have done their work, draining the Earth's spin until it matches the Moon's orbit. That's a very long time from now, so distant that it doesn't really affect anything in your life. But it's a reminder that the rotation you feel tonight isn't permanent. It's part of a longer process, a gradual exchange that's been playing out since the moon was born. The stillness of your night is actually a moment in a very slow transition. The Earth is turning, but it's turning more slowly than it used to, and it will turn more slowly still in the future. Your sense of time, your experience of day and night, is calibrated to a tempo that's always changing, so gradually that no one notices within a lifetime. And that's okay. The tempo is still beautiful, the rhythm still works, the night still comes, and you can still rest inside it. Breathe slowly, feel the weight of your body. The tides are out there somewhere, rising and falling on coastlines around the world. The moon is up there somewhere, drifting imperceptibly away. And you're here, resting, part of the same system, the same ancient dance. I want to take you somewhere very far away now. Farther than the moon, farther than the sun, farther than any place humans have ever been. Let's go to the center of the Milky Way. It's about 26,000 light years from here. That means the light we see from that region left 26,000 years ago, long before writing, long before agriculture, when humans were still living in small bands, hunting and gathering, looking up at the same band of light across the sky that we see today. At the center of the galaxy, there's a supermassive black hole. We call it Sagittarius A, pronounced Sagittarius A star. It's about 4 million times the mass of our Sun, compressed into a region smaller than our solar system. Sagittarius A is spinning. We know this because we can see stars orbiting around it, whipping past at incredible speeds, their paths bent by the enormous gravity. Some of these stars travel at a significant fraction of the speed of light as they swing close to the black hole. Their orbits have been tracked for decades, allowing astronomers to calculate the mass and spin of the invisible object at the center. A spinning black hole warps spacetime in a particular way. It drags space around with it, creating a kind of whirlpool in the fabric of reality. Close to the event horizon, this effect becomes extreme. Nothing can stand still relative to distant space. Everything gets swept up in the rotation. If you could somehow hover near Sagittarius A, time would pass differently for you than for someone far away. Your clocks would tick slower. Light trying to reach you would be bent and stretched. The universe would look distorted, warped by the immense gravity and spin. But from here, 26,000 light years away, none of that touches us directly. The black hole at the center of our galaxy is just a distant anchor, the gravitational hub that holds everything together. The sun orbits it, as do all the other stars you can see. The whole galaxy wheels around that hidden center, held in its grip, shaped by its mass. And even the black hole isn't permanent. Over unimaginable timescales, it will slowly evaporate, losing energy through a quantum process called Hawking radiation. This takes so long that it's barely worth mentioning on any human timescale, but in the very distant future, even supermassive black holes will fade away, leaving behind nothing but a faint mist of particles. When they do, their angular momentum will be released, radiated away into space. The spin they accumulated over billions of years will become ripples in the quantum field, spreading out into the void. The rotation won't truly disappear, it will just become so diffuse, so spread out, that it might as well be stillness. This is the ultimate fate of spin in the universe, not cessation, but diffusion. The motion persists, but it gets thinner and thinner, spread across larger and larger regions until there's no longer enough concentration to notice. It's a strange kind of ending, not a stop, but a fading, not silence, but a sound so quiet it can't be heard. And it's so far away in time that it has nothing to do with your life. The universe will spin for trillions upon trillions of years before anything like that happens. Tonight, the galaxy is turning, the black hole is spinning, and you're here, resting, with more than enough motion to carry you through. Let the vast distances fade. Let the timescales become abstract. They're not your concern. They're just context, background, the setting in which your small, precious moment takes place. The night continues, the rotation continues, and you can rest. There's a concept in physics called entropy. It's often described as disorder, but that's not quite right. It's more like spreadness, the tendency of energy to distribute itself evenly over time. A hot cup of coffee cools down because the heat spreads out into the surrounding air. The coffee doesn't become more disordered, exactly. It just becomes more similar to its environment. The energy difference that made it hot gets smoothed out. This process is irreversible under normal conditions. You can't unstir cream from coffee. You can't unfry an egg. Time has a direction, and that direction is the direction of increasing entropy. Some physicists think this connection between entropy and time is very deep. Maybe the arrow of time, the fact that we remember the past, but not the future, the fact that causes come before effects, is actually a consequence of the universe starting in a low entropy state and gradually moving toward higher entropy. The early universe was very smooth, very uniform, very organized by certain measures. The variations were tiny. Over time, gravity amplified those variations, creating clumps of matter, galaxies, stars. In one sense, this increased complexity, but in another sense, it was the universe sliding toward a more probable arrangement, spreading out energy, increasing entropy, even as interesting structures formed. Rotation is part of this story. As entropy increases, angular momentum disperses. Spinning things slow down. Concentrated vortices spread into broader, gentler flows. The universe moves toward equilibrium, toward a state where nothing much happens because everything is already as spread out as it can be. But here's the thing, we're not at equilibrium yet, far from it. The universe is still full of concentrated energy, spinning objects, temperature differences, interesting structures. We exist in a middle chapter of a very long story, after the smooth beginning but long before the diffuse ending. And in this middle chapter, complexity flourishes. Stars burn, planets form, life emerges, consciousness develops. You lie here thinking about the universe, made of matter that entropy is slowly spreading but hasn't finished spreading yet. You're a pocket of low entropy, a temporarily ordered arrangement of atoms that will eventually scatter. But not tonight. Tonight you're still organized, still coherent, still you. The entropy of your body will increase as you sleep, in tiny ways, as heat radiates from your skin and cells perform their metabolism. But you'll wake up tomorrow still yourself, still a complex pattern in a universe that hasn't yet smoothed you out. There's something encouraging in that. The universe is vast and ancient and slowly winding down, but you're still here. The pattern that is you is still holding together. And for tonight, that's enough. Let the thought of entropy fade. It's a background process, so slow you can't see it, so inevitable you can't fight it. But it's not your enemy, it's just the way things work. And within that working, there's room for nights like this, for rest, for peace. The room around you is probably a comfortable temperature. That's because energy has flowed into equilibrium, more or less. The air, the walls, your body, all at roughly the same warmth. That's entropy at work, making the space around you uniform enough to rest in. Even entropy gives gifts, sometimes. The smoothness of a quiet night is one of them. I've been talking about motion this whole time, about spin and rotation and the dynamics of things. But let me say something about stillness now. Stillness isn't the opposite of motion. It's a relationship to motion. It's what you experience when you're moving in harmony with everything around you. It's the absence of conflict between your motion and the motion of the world. A rock sitting on a hillside seems still, but the hillside is on a planet that's rotating. The planet is orbiting a star. The star is orbiting a galaxy. The rock is moving at tremendous speed, but it's still relative to its immediate surroundings. Stillness and motion coexist. The same is true for you. Right now, you're moving with the Earth, with the Sun, with the galaxy, but relative to your bed, relative to the walls, relative to the air in the room, you're still. And that's the stillness you feel. This kind of stillness is available anytime, anywhere. It doesn't require the universe to stop. It just requires you to be in harmony with what's immediately around you, to match your motion to the motion of your context. Tonight, your context is the turning Earth. The motion is smooth, steady, ancient. You can match it just by lying still, by not resisting, by letting yourself be carried. This is a kind of surrender, but not a defeated kind. It's the surrender of a leaf floating on a stream. The leaf doesn't fight the current. It doesn't try to go upstream. It just moves with the water, and in that moving, it finds a kind of peace. You can be like the leaf tonight. The current is the rotation of the Earth, the flow of time, the drift of night across the surface of the world. You don't have to swim, you don't have to steer, just float, just rest. The motion carries you whether you're awake or asleep. It asks nothing in return. It just continues as it has for billions of years. Let your body soften, let your muscles release. You've been holding yourself together all day, managing a million tiny tensions. You can let them go now. The earth will hold you. Gravity will keep you in place. The rotation will carry you through the night. There's nothing to fix right now, nothing to figure out. The problems of the day can wait in the dark. They'll still be there tomorrow if they need to be, but they don't need your attention now. Just breathe, just rest, just let the spinning continue without your supervision. The stars are out there, turning in their slow arcs. You can't see them from here, but they're there. The same stars that ancient humans watched, the same patterns that have wheeled across the sky for thousands of years. Those patterns shift over time. The constellations slowly distort as stars move relative to each other. In 100,000 years, the shapes will be different. The Big Dipper will have bent out of recognition. New patterns will have formed. But tonight, the stars are where they've been for all of human history. Orion in the winter sky. The summer triangle high overhead in warm months. The North Star, Polaris, marking the axis around which everything seems to turn. Polaris isn't exactly at the celestial pole. It's close, but not perfect. And the pole itself moves over time, a slow wobble called precession. In 13,000 years, a different star will be closest to the pole. The Earth will still spin around the same axis relative to its own body, but that axis will point in a different direction relative to the stars. This wobble happens because the Earth is spinning and also slightly bulging at the equator. The Sun and Moon pull on that bulge, trying to tilt the Earth's axis. But because the Earth is rotating, the pull doesn't tilt it directly. Instead, it makes the axis trace a slow circle in the sky, like a spinning top that's slightly off balance. The wobble takes about 26,000 years to complete one cycle. In that time, the pole star changes, the seasons shift relative to the Earth's orbit, and the whole orientation of our planet traces a patient circle against the background of stars. You won't see this in your lifetime, no one does, but it's happening right now, tonight, as you rest. The slow wobble continues, imperceptible, inevitable, adding another layer of motion to all the others. Wheels within wheels, rotations nested inside rotations, and you, resting at the center of your own small experience, carried along by all of them. Let the complexity fade into simplicity. You don't need to track all these motions. They track themselves. What matters is that you're here, breathing, resting. The night is deep now. The rotation continues. Let me tell you about something beautiful that happens when rotation gets very fast. When a massive star collapses, as I mentioned before, it can become a neutron star. These objects are so dense that a teaspoon of neutron star material would weigh about 1 billion tons. And because they're so compact, and because angular momentum is conserved, they spin incredibly fast. Some neutron stars spin hundreds of times per second. They complete more rotations in a minute than the Earth does in a year. Their surfaces move at a significant fraction of the speed of light. As they spin, they emit beams of radiation from their magnetic poles. If those beams sweep across our line of sight, we see pulses of light, like a cosmic lighthouse. These are pulsars, and their pulses are so regular that they rival the most precise clocks we've ever built. There's something mesmerizing about that. A dead star, collapsed beyond recognition, spinning in the void, flashing its signal across light years of emptiness. No one put it there, no one designed it. It's just physics playing out the way physics does. Pulsars have been used to test Einstein's theories of gravity. Their pulses are so regular that even tiny variations can be detected and studied. When two pulsars orbit each other, their orbit slowly shrinks because they're emitting gravitational waves, ripples in spacetime that carry energy away. This was one of the first indirect confirmations that gravitational waves exist. Now we can detect gravitational waves directly using enormous instruments that measure changes in distance smaller than the width of a proton. These waves come from the most violent events in the universe, colliding black holes, merging neutron stars, objects spinning around each other so fast that they warp spacetime itself. When gravitational waves pass through the Earth, they stretch and squeeze space by an unimaginably tiny amount. You can't feel it. No one can, but the detectors can measure it, and they've recorded the chirps and rumbles of distant cosmic collisions. These waves carry angular momentum too. When two black holes spiral together and merge, their combined spin goes partly into the new, larger black hole and partly into the gravitational waves that radiate outward. The rotation is shared between the remnant and the ripples. So even the motion of spacetime itself, even the invisible waves passing through you right now from ancient collisions, carries the memory of spin. You're immersed in this. Gravitational waves pass through you constantly, too weak to notice, but real. They've been traveling for millions or billions of years, and they pass through you as if you weren't there, continuing on into space. It's a strange kind of intimacy, the most violent events in the universe rippling through your body unnoticed. The angular momentum of colliding black holes, encoded in spacetime, brushing past you in the dark. And you can't feel any of it. You just rest, still and quiet, while the waves pass through. This is part of what it means to exist in this universe. You're embedded in layers of motion you can't perceive, rotation at every scale, from atoms to galaxies, waves from ancient catastrophes, the slow wobble of the Earth's axis, the drift of the moon, the expansion of space itself. All of it continues, all of it touches you, and none of it requires anything from you. The night is a gift. The stillness is a gift. The fact that you can lie here, unaware of almost everything happening around you, and still be safe and resting, that's a gift too. Accept it, let it be enough. Your breath is soft now, your body is heavy, the thoughts can drift. The motion continues, but you don't have to follow it. You don't have to track it or understand it or remember it. It will still be there tomorrow and the day after and for billions of years beyond. Right now, you can rest. The rotation is smooth, the night is deep, the universe is spinning, and you can sleep within it. There's nothing more you need to know, nothing more you need to do. The story will continue on its own. Just breathe, just rest. The motion carries you. It always has. Let the words fade, let the ideas dissolve. Let there be only the quiet, only the dark, only the gentle turning of the world. You're part of it, you've always been part of it. And tonight you can rest. The universe is spinning. All is well. Sleep now. The night holds you. The motion continues. And you are at peace.